Hi buddy, this is me Bilal Malik, and this is the video about your project explanation working and for your understanding purpose. First of all, as you know, I am not a native English speaker, so I'm not good in English speaking, but I will try to explain you everything you need, and sorry for my bad English, you have to bear it. So let's start with the program of frequency controller. First of all, this project, this code for this project is written using Micro C compiler, and let me open it. This is Micro C. Here it is, Micro C for pick. You can download it from Google free of cost. It will not cost you anything, because its cracks are also available in Google, but you don't need to use any crack because your program size is not too much, so you can easily use free version. So first of all, I have defined each and every module of this program by using comments tags, like in C programming, double hash is used to comment in between the program lines. So this module is used to define LCD. It used to define LCD, as we use LCD in your project, in this project, which will display a text frequency controller. At the start it will show value of frequency. So these lines defines to which port of microcontroller we have connected LCD. So it shows LCD RS pin is connected with port B bit 2. So as you can see on schematic diagram, RS pin is connected with port B pin number 2, bit 2, and similarly you can check LCD enable pin is connected with RB3. RB3 means port B bit number 3. Similarly, data pins D4, D5, D6 and D7 are connected with are connected with B4, B5, B6 and B7 respectively. And here RB4 means RB5, RB6 means port B, and 4 defines bit number 4, 5 defines bit number 5, and 7 defines bit number 7. And similarly, this defines the direction of the bits. So you don't need to learn all these things, because compiler will take care of all these things. You just need to write down these statements. So after that, let's this is just declaration of different variables which we will need to calculate frequency and for PMW purpose, and this will use to display frequency on LCD. So first of all, this is the main start of the code. This bit defines port A as input, because we are using port A to read frequency value. So it is used as declared as an input, and as we go on, port C is declared as output, because we are declaring PWM with the help of C port, and that's why we are declared as output. And similarly, we are declaring B port as our output, because we are using this output to display some values on the LCD. And this is optional register, which is used to set the value of frequency or timer, because I have used a timer to measure frequency. And this is a function to initialize LCD because we are using LCD to LCD. So this is the initialization function of LCD, and this is this command is used to clear whatever has written on the screen of LCD, and this command will off the cursor, and this is the initialization of PWM, which we are using to change the output value of voltage, which you will give to rheostat, which you will use instead of rheostat. And this is here we are starting our PWM, and here we are setting the value of our current duty cycle. If you don't know about the duty cycle, I recommend you to study on Google. And this is the main part of our program, because microcontroller will keep doing this from while loop, and similarly here we started the timer 0, and time we are calculating frequency with the help of timer 0, and frequency after timer 0 reach the zero crossing point, frequency value will store in timer value will store in frequency variable, and we will display this value of frequency on LCD with the help of these commands. After that we will check the frequency. If frequency is less than 60%, so it's mean we have to increase RPM of RPM. So RPM are directly proportional to voltage, so we have to increase voltage, we have to increase the duty cycle of the PWM, so we are increasing PWM. If frequency is less than if frequency, sorry, here is a mistake, if frequency is greater than 60, it means we have to reduce the RPM, and RPM is directly proportional to voltage. If there is less voltage, definitely there will be less RPM, so we are decreasing duty cycle, because out of voltage is directly proportional to input voltage multiplied by duty cycle. If duty cycle is less, definitely output voltage will be less. If voltage is less, definitely overall output will be less. If output voltage is less, RPM will also be less. But if frequency is equal to 60, we are always saying current duty cycle is equal to 191, because as you told me 36 is the threshold value of voltage. So after making calculations, 192 is the duty cycle to set voltage always equal to 36. So this is all about this is all about program of a frequency controller. It is, as you can see, it is written in high language, so it is not difficult for you to learn, because these are simple English instructions. There is nothing rocket science in it. You just need to understand these instructions. If you want to know more about these functions, like if you want to know more about LCD initialization, LCD command, you can go to help, click on help, and index right here LCD. Here you can find the whole library of LCD with explanation and how to use it. So it is not a difficult task for you, as you are a student of engineering, so I think you can do it very well. So now let's come to circuit diagram. First of all, start from the input point. This is the connection of supply, 220 volt, for which you want frequency you want to measure. But as you know, frequency supply voltage is 220 volt AC, which is dangerous. So 220 volt AC means it is quite high. You cannot connect it directly with the microcontroller or either with the bridge. So what you have to do while making your circuit practically, you have to use a step down transformer. Let me show you how you will connect it. Go here, components, and find a transformer. So you can purchase a step down transformer from market, And what will be the value of step down transformer? Definitely it will be 220 volt to 220 volt to 12 volt step down transformer. 220 volt to 12 volt step down transformer. Okay, so you will connect it. I'm not using this transformer in simulation because because software will not be able to simulate it. Okay, so while making your circuit, practically you should connect before bridge, you should connect a step down transformer which step down the voltage from 220 volt AC to 12 volt AC. So I am eliminating it now. Okay, what will happen, you will connect your supply here. Okay, and after that supply you will be using step down transformer. Step down transformer will convert this high voltage into 12 volt AC. After that we are using bridge because microcontroller can never read negative voltages, so we are using high bridge to convert negative cycle again into positive cycle. So it's mean we will be getting, let me show you, so in a bridge will convert, what will bridge do? Bridge will simply convert your let's suppose this will be the input. Okay, and what will bridge will do? Bridge will convert, even positive cycle remains same as it is, and what will bridge do? Bridge will convert negative cycle into also a positive cycle, because microcontroller cannot read negative voltage, so we have to find the solution to convert negative voltage into positive voltage. Now here we are using a voltage divider. So question is, why we are using voltage divider here? Because microcontroller read voltage only less than 5 volt, so we are using a voltage divider here to step down voltage to a low value. Here you will use it will be 20k. Okay, so it is, if you study the circuit of the subject of circuit analysis, I assume that you know how to design a voltage divider circuit. So after that we are giving the output of voltage divider to timer 0 pin. Okay, and what will timer 0 do? Timer 0 will always read a 0 crossing, and after 0 timer 0 will read time between 2 0 crossings, and the time between two for example, timer will start reading time from here and up to this point, and time between this point is half of the time of sine wave, half of the frequency of sine wave, or half of the time of over sine wave. So timer will read, timer will read time between two consecutive 0 crossings, and this time we will be using to convert into frequency, because we know that time period is inversely proportional to frequency. So we simply use in code we simply use this logic to convert time back into frequency. Okay, and this is an extra circuitry. We are using this circuit only to detect 0 crossing, because whenever there is a 0 crossing, this LED will glow. And remember, you should connect you should make these points after step down transformer. What I mean, these connections should be connected with low side of step down transformer, otherwise 220 volt AC will definitely burn it. Okay, so this is or these are the components which we need to connect with the oscillator. For example, any computer or any microprocessor is need definitely need some kind of frequency to operate on it. So this is the circuit which on which microcontroller this is the circuit which microcontroller will be operating. So we are using 8 megahertz crystal, and so it's mean microcontroller will perform instructions 1 by 8 megahertz per second. 1 by 8 megahertz, so you can say it will become microsecond. So this circuit is this is for M clear button, just like the button of the restart button of your computer. If you push the button, microcontroller will restart, but we don't but I just connected a logic high with it. So it means whenever you will turn on it, it will be remain turned on. It will not be turned off. Okay, so you have to connect 5 volt. You should connect 5 volt here. Okay, and because this is we are designing this circuit in software, so when you purchase actual PIC microcontroller IC, there will be more pins which are basically hidden in software. These pins are VDD and VSS. VDD and VSS. Okay, so you also you should connect 5 volt with VDD pin and ground VSS pin. So in PIC 16F877 microcontroller, there are 2 VDD pins and 2 VSS pins. So you should connect VSS pins with the ground and VDD pins with 5 volt. Okay, and now come to the main part of our circuit. Here it is. What will happen when microcontroller will read frequency and display it on the LCD? Let's suppose we are starting it. So what will happen? Okay, let me check it. So what will happen when you turn on the when you turn it on? What will happen? Microcontroller will read the frequency and display it on LCD. As you can see, microcontroller is displaying a frequency. Microcontroller is displaying 60 Hz frequency. But what happened if we change the frequency? Let's suppose now stop it. Let's suppose we changing the frequency to 50 Hz. So let's see what microcontroller are displaying now. So you can see it will take some time because I have included the display, because microcontroller takes some time. So here it is. As you can see, we give the input frequency of 50 Hz and the frequency, and LCD is also displaying frequency of 60 Hz. So similarly, when frequency is less than 60,000, as you can see, we use the CCP to pin and PWM. So it is blinking. As you can tell, it is becoming red, blue. Red means ground, high and low. So when frequency is lower than 50 Hz, and PWM will increase. When frequency is less than 50 Hz, PWM will decrease. So let me show you the real picture of PWM. So here you can see oh, where it is. Oh, I don't know what is the issue with the oscilloscope, but as you can see, oscilloscope is not I don't know why it is not working, but as you can see here, you can see the changing value of PWM. So what you have to do, you should connect your 48 volt here, 48 volt at this point, and let me stop the simulation. What you do, you should connect 48 volt here, and ground of 48 volt at this point, and output you should I have just use motor for demonstration purpose, and you should take output from this point. So at this point you will be getting variable voltage according to frequency. So this is all about your circuit, but what you have to do, you one extra thing you have to do, you just have to design 5 volt power supply, which you can easily design using 78005. okay, because you will need 5 voltage to connect here. You will need 5 voltage to connect with LCD, and sorry, here we also need 5 voltage. You will need 5 voltage to connect here. Oh, what is happening? 5 volt with microcontroller, and remember you can design 5 volt power supply from your main 48 volt power supply, but just simply going by connecting input voltage here, and you can take output from here by connecting ground with the ground of your battery. But remember that ground should be same for all the points, and you should not connect ground here. Supply should be isolated. Okay, so I think this is all about your project explanation. But if you need any if you don't understand anything, you are welcome to write me in email. And thank you so much for your patience. I was out of city on a business trip, that's why I was not able to deliver you your project on time. I hope you will bring more clients from me. Thank you for watching this video. Allah Hafiz.